Hey everyone, welcome to Unit 1, Lesson 1, Day 6. We're going to be talking about the function and graphs today. Our goals for today are to review the coordinate plane and understand how to plot points. So if you forgot how graphs work, like with the XY coordinates and things like that, we're going to talk about that briefly and get a little bit of practice with that just to refresh your memories. And then we want to understand how to use the graphs of functions to evaluate them, right? So if I gave you an input, could you find an output, or could you find an input given an output using a graph? And sometimes using a graph can be a lot quicker than trying to use the rule, right, which we talked about at the beginning of this unit. All right, so let's start off with some review. We're going to go over how we plot points on a coordinate plane, right? So probably back in middle school, you were introduced to something called an ordered pair, and it might look something like this, where you get like a 2 comma 4, and it's inside of the set of parentheses. So this is what's called an XY coordinate, and it gives a location on a graph. All right, so the first number that we see there, this 2, right, tells you where you are on the x-axis. So when we're looking at this graph here, the x-axis is the horizontal line, usually labeled with the numbers, right? So this would be our x-axis. Goes across the graph horizontally. All right, that means left to right. And then the second number, right, is a y location. It's a y coordinate. So it tells us where we're at vertically on the graph, and that's this guy right here. That's the y-axis. So there we go. And the y-axis runs vertically, or up and down, through the middle of the graph. And it's also usually scaled and labeled just like this. Okay, so let's try plotting a few of these. So in case you forgot how this works, we're going to start with the 2, 5, and I'm going to write this big here, right, so we can talk about this, right? So we have 2 comma 5, and remember the 2 in this coordinate is an x coordinate, right? So when I go to my x-axis, it's telling me that we're located at an x value of 2, right? So this is -5, -4, -3. We're looking for an x value of 2. So this point right here, also very important. This is our origin, so this is usually where we start. So if I want to go to 2, I'm going to start at this point, and I'm going to count to the right 2, and that'll put me on an x coordinate of 2. But I'm not going to mark my point there because I still have to figure out where I am vertically. All right. So the next coordinate, this y coordinate, is a 5. So that means I'm going to go up 5. So I'm at an x coordinate of 2, and then I have to go 1, 2, 3, 4, 5. And this is the location that they want me to put a point at, right? So I'm going to go right here, and I'm just going to plot a point. So this has an x coordinate of 2 and a y coordinate of 5. Okay, and we're going to do it again. This time we're going to do it with the -1 comma 5. So it's telling me that we have an x coordinate of -1, y coordinate of 5. Right, so here's the -1 on the x-axis, and then the +5 on the y-axis puts me right here. So these coordinates are almost kind of like a map, like go this far to the left or go this far to the right, then go this far up or down. So that's kind of what those coordinates are telling you, right? So this one's at -3, 0. So again, remember, it goes x first, y second. All right, that's probably the most common mistakes is students get those mixed up. They'll go y first, x second, and get the numbers switched around. So for this one, we're going -3 comma 0. So that means I'm going to be at -3 on the x-axis. So I'm going left 3, and then at 0 on the y-axis. And remember, they don't have the 0 on here, but this is 0 right here for both the x and the y. So we call this 0 comma 0 right here. All right, so we're just going to go to the left 3, and then we're not going to go up or down at all because the y coordinate is 0. We don't have to go anywhere. So I'm just going to plot a point right there on the x-axis. Next point here is at 0, -3. Right, so notice that the numbers switched on us there. Well, that means that on the x-axis we're at 0, so we're going to stay right here. But on the y-axis we're at -3, so I got to go down 3. So 1, 2, 3. That means my point's going to be down here. I did not go left or right at all because x was 0, but I did have to go down 3 because y was -3. All right, let's try a couple more here. We got -4, -1, so that means I'm going to go to the left 4, right, to -4 on the x-axis, and I'm going to go down 1 to -1 on the y-axis. So we got a point right here. All right, and then our last point here is at 1, -4. So that means we're going to go to the right one because x has a value of 1 there, and the y coordinate is at -4. So I'm going to go down here and go to -4 on the y-axis, plot a point. All right. So that's all there is to plotting points. Give the practice problem a try, see how it goes, get used to plotting those points. All right, so now that we've kind of got a feel for how the coordinate plane works, we know how to plot points, we're going to take a look at the graph of a function and see how we can use a function to help us, or use a graph to help us evaluate a function. All right, so when we look at a graph of a function like this right here, what we're seeing is a collection of those ordered pairs that are generated by the function. And so it's like a whole bunch of those points plotted at once on the graph. And when you do that, sometimes it starts to make a shape. So if you can imagine, these are actually who knows, like dozens, hundreds of points being plotted at once, and it makes a nice smooth curve. All right, so that's what we're seeing here. In most cases, when we graph a function, you will see some kind of shape form as you plot the points, right? So you might see a line or a parabola. In this case, we just see a general curve going on here. All right. The nice thing about these graphs is that we can use them quickly to understand the nature of a function or its behavior, but we can also use it to evaluate a function in either direction. All right, so watch what I do here. All right, so we've seen this before, right? So when we see this f of 2, right, that means that we have an input of 2. Right, so this is an input, and inputs are x values. Right? So remember that x used to be there. Well, that's an x value of 2. So what I'm going to do is I'm going to go to my graph. Right, I'm going to go to my graph over here and I'm going to find an x value of 2, which is right here, and I'm going to go up to my function, and notice that when x is 2, this is where my function is, right here. And look at the corresponding y value. It's 4. So that means when I put a 2 in, I get a 4 out. So I know instantly, just by looking at the graph, that f of 2 equals 4. All right, so let's try it again. Let's look at this one. All right, in this one, they're telling us that x is 4, right? So our x value this time is 4. So I'm going to go over here to my graph. I'm going to find 4 on the x-axis. I'm going to go up to that curve. Here's the point on the graph where x equals 4, and then I look at the corresponding y value, which is 3. So when I put a 4 in, I get a 3 out. All right. And you might remember this from previous lessons, right? So this one's kind of different. They didn't give us the x value. Instead, they gave us the output, right? They didn't give us the input. They gave us the output. And the output is represented by y, right? So they gave us a y value, and they want us to find the x value. No problem. I can go over here to my graph. Y is the axis that runs up and down, right? So I can go here and I can find 7 on the y scale. Go over to my function, there's the point where y equals 7, and look at my corresponding x value. Right? So it's like going backwards, right? Instead of getting the x value and going up to the y value, we're starting with the y value and going back to the x value. So for this one, when y was 7, or when the output was 7, the input was -2. So I know that x equals -2. All right, so that's how you do inputs and outputs with a graph instead of a rule. Try the practice problem, see if you can do it too. All right, guys, welcome back. We're going to try one more here. This one looks a little bit different than the other graphs that we've done, but it is still a function, even though it doesn't make a shape. Remember, I said most of the time a function will make a shape when you plot all the points, but with this one, it did not make any kind of recognizable shape. It's just a collection of points that was generated by some function somewhere. All right, but it still works the same way. So when I look at this problem, what they want me to do is they want me to figure out what f of 1 is. So they're telling me the x value is 1. So I'm going to go to my x-axis, I'm going to find 1, and then I go up until I hit a point. Okay, and notice that I hit a point right here, and its corresponding y value is 4. So when I put a 1 in, I get a 4. Right? So no different than the last problem that we did. It's just that we don't have a shape over here. It's just a bunch of points, but we do it the exact same way. All right, so this one, our x value is 9. All right, so I'm going to go to my x scale over here. I'm going to go over to 9, and we actually got really lucky here. We don't have to go up or down at all. There's actually a point right on 9. Okay, so when I put a 9 in, the corresponding y value is 0. All right, let's take a look at this one. This one is the backward situation, right? They want us to find the input given the output, right? So they give us a y value of 10. So I'm going to go to my y scale this time, not the x scale. So I'm going to go to my y scale. I'm going to go up to 10, and then I'm going to go over either left or right. In this case, I'm going to go right until I find a point that's on the function. And here's my point where y equals 10, and then I go to my corresponding x value, which will be down here at 8. All right, so to get a 10, I have to put an 8 in. All right, guys, give that one a try. I created a practice problem that looks just like that for you to practice with, so give it a try, see if you can do it too. All right, that'll end the video there. Have a great day. Let me know if you have questions.